3, Inequalities and Absolute Values. So this is the beginning of our third unit, and in this video we're going to talk about learning target 3A, which is all about solving inequalities. So in this first part we're going to learn how to solve inequalities using addition or subtraction, or multiplication or division, and then graph their solution step. We will also go through some multi-step inequalities, how to solve those, as well as graph their solution set. So let's start talking about some basic properties of inequalities. So if A, B, and C are real numbers, and if I start off with the statement that A is greater than B, then if I were to add the same number to both sides, so if I add C to both sides of this inequality, then that will not flip the inequality. So if A was bigger than B to begin with, and I add the same number to both sides, then that side with the A is still going to be bigger than the side with the B. Likewise, if I start off with A being less than B, and I add a number to both sides, then A plus C is still less than B plus C. This statement also holds if we have a less than or equal to, or a greater than or equal to. Let's look at what happens with multiplication. So if A, B, and C are real numbers, but we also are going to assume now that C is bigger than 0, so C is going to be a positive number in this case. Then let's look at what happens. So if A is bigger than B to begin with, and I multiply by a positive number to both sides, then the inequality sign is left unchanged. So A times C is still going to be bigger than B times C. Likewise, if I have that A is less than B, and I multiply by a positive number to both sides, then A times C is less than B times C. Again, this statement will also hold true for our less than or equal to, or our greater than or equal to. Let's look at our third case now. So if A, B, and C are real numbers, but now that C is going to be less than 0, meaning C is a negative number, then we're going to have to see what happens this time. So if I start off with A being bigger than B, and I multiply by a negative number, what ends up happening is that the inequality sign will flip, and A times C is less than B times C. Likewise, if I start off with A being less than B, and I multiply by a negative number, then the inequality sign will flip, and A times C is now bigger than B times C. Again, these also hold for our less than or equal to and greater than or equal to. If we're going to summarize that, what that means is if we multiply or divide by a negative number, then we have to flip that inequality sign. And this right here is everything that inequalities can kind of boil down to. Adding or subtracting does not change anything. So there was no flip up here. There was no change with the inequality sign in our first case. And if I multiply or divide by a positive number, again, there is no change in the second case that we looked at. But when I multiply or divide by a negative number, I have to flip the inequality sign. When we go to graph inequalities, there's a couple things we have to keep in mind. The first is that we first have to solve the inequality before we graph it. And the way that we will solve that inequality is by isolating the variable. So we first have to solve, and then we can graph it. The second thing to keep in mind is that we graph on a number line. And the reason we graph on a number line is because we only have one variable. So on a number line, it's just representing one variable. If you guys have seen coordinate planes where you have both an x and a y axis, the reasoning that happens is because we have two variables, an x and a y variable. But with inequalities in this unit, we're only going to look at inequalities in one variable, which means all of our graphs will be on a number line since there is just going to be one variable. And it doesn't matter what letter we use for that variable, we're always going to draw our number line horizontal. The next thing to keep in mind is that if we have a less than or a greater than sign, we are going to use open circles on our number line. And the reason behind that is because we do not want to include our endpoints. So an open circle means that you're getting really, really close to that number, but you're not actually including that number. On the flip side, if we have a less than or equal to, or greater than or equal to sign, we want to use a closed circle or a filled in circle, and that's because we do want to include the endpoints. So when we have that equal to bar that gets added to it, it means I can equal that value, so I want to fill that in and make it a closed circle so that I can include that endpoint. Okay, let's start looking at a couple examples. The first two are just going to deal with graphing. So in our first example, it says graph the solution set for n being less than 1. So we're going to draw our number line. On my number line, yes, I could label a bunch of numbers on here, but the one I care about is 1, since that's what we're comparing our variable to. Our inequality says that n is less than 1, so the first thing I notice is I have an open circle at 1 because I do not have an equals to bar, so I want to not include that endpoint. And now I have to think about, well, which way do I shade on this graph? Because the shading on a number line when I'm graphing represents the numbers that I want to include in this. So my inequality says n is less than 1, which means I want all the numbers that are less than values of 1. So if I put some more numbers on this number line, I would have 0, -1, I would have 2, and then I would have 3. I want all the numbers that are less than 1, which means I want all the values to the left of 1. So I'm going to go ahead and shade everything to the left because those are all the values that are smaller than 1 or less than 1. Let's look at our second example. So our second example says graph the solution set for a being bigger than or equal to -2. So let's go ahead and draw our number line. I'm going to have -2, and I'll put a couple more on here just for reference. So I have -2, or I'm sorry, that wouldn't be -1, that would be -3, making sure we're going smaller to bigger, -1, 0, and I guess I could put -4 on here, why not? So the first thing I need to think about is at -2, will I have an open or a closed circle? I'm going to have a closed circle because I have that equals to bar, which means I want to include -2. Now I have to think about the type of inequality. So this inequality statement says a is greater than or equal to -2, which means I want all the numbers that are bigger than -2, so I would shade all this to the right because I want everything that is greater than or equal to, so all the numbers that are bigger than. And there are our first two examples. We weren't asked to solve, we were just asked to graph, and in this case there wouldn't actually be anything to solve for in either of those two because the variable is already isolated. Okay, let's look at example 3. So example 3 says solve x minus 15 is greater than -12, then graph the solution set. So I can't go ahead and graph right away because my variable here, which is our x, is not isolated. So the first thing I have to do is isolate that variable, which is our x. To do that, I would add 15 to both sides. And when I add numbers, there's no need to worry about the inequality sign. That inequality sign will not change, so I'll still have x is greater than, and then -12 plus 15 will give me +3. So x is greater than 3 will be our inequality that we have solved for. Now we have to go graph that on our number line. So on our number line, I definitely want to make sure I have 3 on there, and for reference, I'll put one number smaller than and one number bigger than, or one integer, I should say, smaller than and bigger than. And let's think about this. At 3, will I have an open or a closed circle? I'm going to have an open circle at 3 because I'm not including 3. There's no equals to bar. And now I have to think about which way will I shade. Will I shade to the left of 3 or to the right of 3? We're going to go ahead and shade to the right of 3 because I want everything that is bigger than 3. So our inequality says x is greater than, and all these values that I'm shading is representing what x could be equal to. So because x is bigger than 3, I want all the values that are to the right, so I will shade to the right. Okay, let's look at our fourth example. Why don't you guys pause the video and try example 4 on your own first, and then we'll check it together. Okay, let's check example 4. I need to isolate that variable of x. So to get x by itself, I could add 3 to both sides. When I add numbers, that will not change the inequality. It's a little messy. So I have x, and then on the other side, I'm going to have 13 because I added 3. So our inequality says 13 is greater than or equal to x. Technically, I've solved it, but that's kind of hard to read. We prefer to have the x on the left-hand side and compare it to the number. That will definitely help us when we go to graph. So I'm going to rewrite this instead with x on the left-hand side. I'm comparing it to 13, and I want to make sure that just because all I'm doing is rewriting it, I want to make sure I'm not changing the problem. So when I think about our inequality sign, it's opening towards 13. So if you think about it as like an alligator, it's kind of eating the 13. So when I rewrite this then, yes, I'm flipping the inequality sign, but I'm doing that because I also flipped where the x and the 13 are. So our original problem that we solved for said 13 is bigger than or equal to x. That's the same thing as saying x is less than or equal to 13. Either of these are correct answers because they are equivalent. The bottom one, though, is just going to help us graph a little bit easier. So when we go to graph this now, I'm going to have 13 on our number line. Will I have an open or a closed circle at 13? I'm going to have a closed circle because of the equals to bar. And now I have to think about which way will I shade. Will we shade to the left or to the right? For this inequality, because it says x is less than or equal to 13, we want to shade everything that is smaller than, so we'll shade everything to the right. To give you guys a little bit of reference, I'll put 2 more numbers on there of 12 and 14. Okay, let's look at our 5th example. So our 5th example says x divided by 3 is less than -2. What could I do to get that variable x by itself? I'm going to go ahead and rewrite the problem. And to get that x by itself, I would want to multiply by 3 so that the 3's can cancel. But whatever I do to one side, I have to do to the other. So on the left side, we have x. On the right side, we get -6. Now, what will happen with that inequality? Do you guys think that inequality will flip or will not flip? In this case, the inequality will not change because I am multiplying by a positive number. So in this case, we multiplied by a positive number, which means the inequality sign does not flip. And now we have solved our inequality. So we have x is less than -6. When we go to graph this, why don't you guys pause the video right now and try graphing it on your own first, and then we'll check the graph. Okay, on our graph, I have to have -6. I would have -7, -6, -5, let's say. At -6, we will have an open circle because there is no equals to bar. And because the inequality is x is less than -6, I will be shading all of this to the left from there. Okay, let's look at our 3rd example. So in our 3rd example, it says -9y is less than or equal to 63. So we've got to solve this guy. What could I do to get y by itself? Well, I could go ahead and divide through by -9. When I do that, we get y, and then 63 divided by -9 is -7. But now I have to worry about my inequality because I'm doing multiplication or division. So what do you guys think? Will the inequality stay the same, or will the inequality flip? In this case, the inequality is going to flip because I divided by a negative number. So on the side, I'm going to write that out. So we divided by a negative number, which implies that we need to flip the inequality symbol. Lost the u. So to solve this, we get y is greater than or equal to -7. Now let's go ahead and graph. So on our number line, we have -7, -8, and -6. Why don't you guys pause the video and do the graph on your own first. Okay, let's check it. So at -7, we're going to have a closed circle. Well, that was a really big circle. Hold on. It's a little obnoxious. So at -7, we have a filled-in circle. because of the equals to sign. Now our inequality says y is greater than or equal to -7, which means I want to shade to the right because I want everything that is bigger than or equal to it. Hey, why don't you guys pause the video and do example 7 on your own first. Okay, let's check example 7. So example 7 says 4x is less than -8. So we want to solve this guy 4x. So to do that, we could divide through by 4 on both sides, and we would get x, and we'd get a -2. What do you guys think? Does the inequality sign flip, or does it not flip? In this case, it is not going to flip because the number we divided by is a positive number. So because 4 is positive, then there is no flip in the inequality. So we get x is less than -2. When we go ahead to graph it, remember we're on a number line because we have one variable. I will have -2, let's write -1, I keep doing that today. I have -3, oops, come on pen, -3, -2, -1, always making sure to go smaller to bigger. At -2, we will have an open circle because there's no equals to bar. And when we shade, we are going to shade to the left-hand side because everything, it says x is less than or equal to -2, and all of these numbers that I am shading in are less than -2. Okay, let's look at some little bit more complicated examples. So in all of these past examples, they were what we would call one-steppers because it took me one step to be able to solve this inequality. Now let's look at what happens if I have to do more than one thing at a time. We can still handle it, we just take it one piece at a time. So let's look at example 8. It says 9 plus 4a is greater than 21. So I'm going to go ahead and highlight our variable that we're trying to find. So I'm trying to isolate the a. The first thing I want to do is subtract the 9 to the other side. So we get 4a still, and then we get a 12. Remember, when we add or subtract, that inequality can never change, so it's still a greater than sign. The next thing we'll want to do is divide through by 4. So I'll have a, and then 12 divided by 4 is 3. And we have to think about, since we did division, will this inequality sign flip? What do you guys think? So in this case, this inequality sign is not going to change. Let me get a little bit clearer. So we'll still have a is greater than 3, and the reasoning is that we divided by a positive number, so there is no flip. Now that it's solved, we can go ahead and graph. So I'll put 3, I'll put 2 and 4 on here for reference, and when we go to graph this, we have to think about open or closed circles. So at 3, what do we have? An open or a closed circle? We have an open circle at 3 because there's no equal to bar. And think about what direction you're shading. Will you shade to the left or will you shade to the right? We will be shading to the right because it says a is greater than or equal to 3. So I want every number that is bigger than 3 shaded in. 4 is definitely bigger than 3, so I'm going to shade all this to the right. Okay, why don't you guys pause the video and do example 9 on your own first, and then we'll check it together. Okay, let's check example 9. So example 9 says solve -5 times y, so our variable this time is y, minus 4 is less than 6. So the first thing I'm going to do to solve this is add 4 to both sides. Remember, when we're adding or subtracting numbers, I can't change the inequality sign. It will never flip, so I get -5y is less than 10. Now I'm going to divide through by -5, so I get y, and I'll get a -2. And what do you guys think? Do I keep the inequality sign the same, or do I flip the inequality sign? This time we would have to flip the inequality. Whoops. So I would get y is greater than -2, and we flipped it because we divided by a negative. So now we have solved it, and y is greater than -2. Now let's go ahead and graph this guy. So I have -2, -3, -1 on my number line. At -2, I have an open circle because there's no equal to bar, and we say y is greater than -2, so I want to shade to the right to get everything that is bigger than or equal to, or not equal to, just strictly bigger than -2. Okay, let's look at example 10. So in example 10, it says solve 6n minus 1 is greater than or equal to 3n plus 8. So we've continued to kind of make this a little bit more challenging, one example at a time. So the reason this is a little bit more challenging is I now have 2 places where I have my variable. But back in our last unit, we were able to combine like terms. We learned how to solve equations, and we're going to use those same skills here. So the first thing I'm going to do is combine and move the 3n to the other side by subtracting 3n. Again, because I'm subtracting, there's no inequality sign that flips. So 6n minus 3n will give me 3n minus 1 is greater than or equal to 8 still. Now this looks similar to examples 8 and 9, and I know we can solve it from here. So our next step would be to add 1. Again, when we're adding or subtracting, the inequality sign will never change. So we get 3n is greater than or equal to 9. The last thing we have to do is divide by 3 to get n by itself. So I get an n, and I get 3, since 9 divided by 3 is 3. What do you guys think? Will the inequality sign flip, or will it stay the same? In this case, the inequality sign will stay the same because I divided by a positive number. So our final answer then will be n is greater than or equal to 3. To finish out this problem, we're going to go ahead and graph it. So I have, let's say, 2, 3, and 4 on here. I have a filled in circle at 3 because of the equals to bar, and because we're greater than, we're going to shade all the way to the right. Okay, let's look at example 11. So example 11 got us a little bit more complicated again. So it says 6 minus 3x, so I have one place with an x so far, is less than or equal to 5x plus 4 minus an x. Woo, okay, now we've got 3 places with an x, but that's okay, we can take it one step at a time. So the first thing I want to do is think about on either side of the inequality, can I combine any like terms? What do you guys think? Are there any like terms that I can combine on either the left or the right, or maybe both? Well, in this example, we can combine some like terms on the right-hand side. So I'm going to just rewrite the left-hand side. So 6 minus 3x is less than or equal to. On the right-hand side, 5x and negative x are like terms, and when I combine those together, I get 4x, and then the plus 4 is going along for the ride. Now from here, this looks similar to like example 10 did, where I had yes and x on each side, but we know how to solve that guy. Why don't you guys pause the video and finish this example out on your own? Let's check it together. So I'm going to go ahead and move the 4x to the left-hand side by subtracting. So I'll get 6 minus 7x is less than or equal to 4. The next piece I want to do is subtract 6 to the other side to get negative 7x is less than or equal to negative 2. From here, I need to move the negative 7 to the other side by dividing. So I'll have x, and then I'll end up with a positive 2 over 7 because of the double negative. And what do you guys think? Will the inequality sign flip, or will it stay the same? In this case, the inequality sign will flip because we divided by a negative number. So we get x is now greater than or equal to 2 over 7. Now, I think this might be the first example we're seeing with a fraction. That's okay. We can still graph that on a number line. So I'm going to plot 2 over 7. I know that I have a closed circle because of the equals to bar, and the inequality is a greater than or equal to, so I'll be shading all of this to the right because I want everything that is bigger than 2 over 7. Okay, let's look at example 12. So in example 12, we also have a little bit more that got added in here. We now have these parentheses that we're working with. Well, we've worked with parentheses before, and we know that we have to distribute. So we're going to first distribute the 3 to both terms. So we get 3x plus 3 then minus 4x is greater than or equal to negative 5, because all the rest is still there. Now from here, why don't you guys go ahead and finish out this example and we'll check it together. So the first thing I notice is I want to combine my like terms on the left-hand side. So 3x and a negative 4x can get combined to be negative x. The plus 3 is still there, and I still have the greater than or equal to negative 5. From here, I can subtract 3, and I have negative x is greater than or equal to negative 8. The last thing I have left to do is to divide through by negative 1. So I end up with x and a positive 8. Now what do you guys think? Will my inequality sign flip or will it stay the same? Since I'm dividing through by a negative, my inequality sign is going to flip. So I'll end up with x is less than or equal to positive 8. We can graph that on our number line. We've got 8. Will we have an open or a closed circle? We will have a closed circle because of the equals to bar. And what direction will we shade? To the left or to the right? We will shade to the left because we want everything that is less than or equal to 8 in this case. So everything that is smaller than 8. Okay, we have 2 more examples left in this section. So why don't you guys pause the video and do example 13 all on your own first, and then we'll check it together. Okay, let's check 13. So the first thing I'm noticing is the parentheses. So I need to deal with these groupings, and I'm going to distribute that 4 to help get rid of those parentheses. So I have negative 4 less than or equal to 24y minus 48 minus 2y by distributing that 4 there. From here, I can combine my like terms on the right-hand side. So both the 24y and the negative 2y are on the same side of the inequality, so I'm going to go ahead and combine those, and that will become a 22y, and then minus 48 is still there. From here, I want to get y by itself, so I'm going to add 48 to the other side, and I'll get 44 is less than or equal to 22y. To solve for this guy, I'll have to divide through by 22, so I'll end up with 44 divided by 22, which will give me 2, and then I'll have my y. Because I'm dividing through by a positive number, the inequality sign will stay the same. So I've now isolated my variable, and I have 2 less than or equal to y. The issue with this is when I go to solve this now and graph it, it's already solved, but when I go to graph it, it's kind of hard to think about it because we are used to having our variable come first. So I want to rewrite this so that I have y and compare it to 2. Now remember, we want to pay attention to what the original kind of solution was that we got. Our alligator, or our inequality sign, is eating the y, which means it should still be eating the y when we rewrite this. So we get y is greater than or equal to 2. And that's the same thing as saying 2 is less than or equal to y. So either of these answers will work, it just depends on which way you prefer it. Now when we go to graph it, I can put 2 on my number line. I have a closed circle because of the equals to bar, and we are shading to the right because it is greater than or equal to 2. Okay, our last example on here. So again, I want you guys to go ahead and pause the video and do example 14 on your own first, and then let's check it together. Okay, let's check example 14. So the first thing I'm going to go ahead and do is distribute that negative 3. So we get negative 3x minus 9. Make sure we distribute the negative with the 3. Plus 9x is still there, less than negative 15. So none of that changed when we distributed the negative 3. From here, I can go ahead and combine like terms on the left-hand side that I have. So negative 3x plus 9x will give me 6x. The negative 9 is still there, less than negative 15. From here, actually I think I can fit it underneath. Let's go ahead and add 9 to both sides. So we get 6x is less than negative 6. Now I can go ahead and divide through to get x by itself. So we get x and a negative 1. And what do you guys think? Will the inequality sign flip or will it stay the same? In this example, it will stay the same since I'm dividing through by a positive number. So we were able to solve our inequality and we got x is less than -1. From here we can go ahead and graph. I will have an open circle because I don't have an equals to bar, and our shading will be to the left because x is less than -1. So all of this to the left. Everything that is less than or smaller than that -1 value. Okay, I know you guys can see example 15 at the bottom, but that will come in our next video. So in this video, we just focused on how can I solve a bunch of different types of inequalities and then graph their solution set.